Hi there, welcome back to the channel. This is the second video in the restoration series for the Grundig 2100, the second one that I've done. And things went a little bit for a loop this week. I had different plans, but life got in the way. So I only managed to get through part of what I had planned. But it's quite interesting because it's the part that actually I find most challenging. It's the AM/IF section, testing that, aligning that, and then doing a test at the end. So the results were actually quite pleasant, but I'll let you wait and see.
Okay, we're into the alignment, adjustment, and all that stuff. And one thing I've got to mention, you've got to get a full service manual with these satellite radios. They exist. This one I got from radiomanual.eu. You can get them from nvhr.nl. You can get them from all sorts of places. Go to Google, type in Grundig Satellit 2100 service manual, and then you get a lot of options. And what I did was I just, you can see here, this one's got color pictures. It's a color scan. So I just looked around for one with the best resolution, and I was ready to go. Now, this thing is all in German. And as my German is, well, non-existent, I actually did a translation of this for the last one, for the first 2100 that I did. I translated this initial section. As you can see here, it says Chassis Ausbau, Gleichstromabgleich. Now you can stop laughing. My accent is terrible. But I did translate it with the help of some other viewers who are German. And this thing is, there's a description, there's a full description here of how basically how the circuit works. It describes the difference between the 2100 and the 2000. So it's all useful stuff, but the stuff we're interested in is here. And here I'm going to start, there's the opening of the chassis, but here I'm going to start with the DC adjustments. And it says no signal, VB, the battery 9 volts, medium wave depressed. Okay, fine. Then there's a potentiometer R631, which is a 2K pot, sets the quiescent current of the complementary pair of transistors, so the output pair, to 6 milliamps plus minus 1 milliamp. So you use a milliampere, use milliamperes instead of the existing wire bridge to the collector of GD364. So we'll find that on the drawings. The speaker connected must be terminated with impedance of 4 ohms and the volume control turned down. What are we talking about here? Let's have a look at the schematic. Here's the schematic, and we're going to look at this section over here. I'm actually trying to find that bridge, the break. Here we go. This is it here. You see that X over there? Adjustable with R631. 631 is that guy over there. So you break this bridge, which at the moment is shorted with a solder blob. You break the bridge, you put a milliammeter across it, and then you start adjusting this. You switch the radio on medium wave, no signal, volume down, and you're just setting the current, the starting current, the quiescent current of these going through these two transistors. And you can see that's what it's doing, right? It's coming through here, through here, through here, through here, and that sets the quiescent current. You're going to set that to 6 milliamps plus minus 1 milliamp with a supply voltage of 9 volts. Now, where is this thing? This is where the full service manual becomes really handy. We're going to look for this board. Service manual is here. Let's try and find the amp board. It's not it. AF board. Here we go. The AF board. And we've got to find that break. And I happen to know, there it is. Boom, 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 boom. Resolution isn't that great, but this is it here. You see that there? That is the break. And you have a blob. You can see the wire, the PCB track has a crack in it. And the idea is that you have a solder blob across there. You break that and you adjust the pot. Now 631 is that pot over there. And the way to really look at this is, if you're looking at from the back where the two transistors are, you've got one there and one there. I think it actually shows you on the drawing of the radio. I'm not sure. Yep, here it is. You can actually see it there. See how useful this thing is? There it is over there. So there's two pots here. This is 640, there's 631. You can reach it through the back. Yeah, that's all you need to know. Okay, what else do we need to do? Let's go and look at, let's go and do it. Yeah, that's easier. Let's go do it. Now with a bit of braid soldering iron, I'm going to desolder that patch that they have over there. At the moment it's just a big blob of solder, nothing special. We're now left with a little gap on the PCB on the track. We now just do a quick test with the ohm meter, just to check for continuity, make sure that the break is actually made. And we now connect the milliammeter across that patch. I've just found the easiest points to connect to, but basically our meter is across there and we switch it on. And we now have to put the volume on minimum. It's set to medium wave. And we switched it on and we were a little low, actually within spec, but let's go to the back there where I showed you. We've got our potentiometer. And now when we start turning that, we can make the adjustments. This is not instantaneous. There is quite a delay between, it's settling down. So you've got to be careful. Just take your time. And it's very, very touchy, as you can see. But we'll get there. A little bit of trial and error. Too low. Just a little bit more. I'm now splitting hairs. Doesn't have to be that accurate. Yeah, I think I'll settle for that. It's good enough. Okay, now we're going to put this patch back. And this is when you realize that putting a patch back is not as easy as removing it. Whenever you don't want to have a solder bridge, you get one by mistake. When you want to make it on purpose, it's not that easy. So what I did is I just got a very fine little thread of wire and I put it across there. It serves just to help the solder flow across. Let it dry. It's a little bit difficult, but we're getting there. Yep. Once it's done, we now just cut the excess wire and we are good to go. Perfect. Okay, that's been done. We've adjusted that one. So we have completed this one here. And now we go to 2. 2 says to set the emitter current of transistor 18 with R557 so that the voltage drop of 1.4 volts is achieved across R558. Okay, where is this? T18. Well, here's T18 over here, and they want us to set the emitter current across that resistor so that it gives us a 1.4 volt drop over here. It's adjustable with R557. R557 is here. So we have to find these guys again as well. We need to find that resistor, R558 and R557. Back to the service manual. Now these 2 points you're looking for are actually on the IF board. And there's R557 and there's R558. They actually show us 1.4 volts. Now identifying that one is not difficult. You can see it if you look at the board. All you do is you find a reference. In this case, we've got these switches over here, or the plug over here. And you've got 1 IF transformer, 2 IF transformer, 3 IF transformer, 4. And that's behind there. So you can see that. And then you've got to identify this resistor. This can be a little bit more tricky. And yeah, okay, I'll probably go on the underside and try and find these 2 connectors. You could also find something more discernible, like the emitter of the transistor itself. Click your voltmeter to there, and that takes you to that point. And then that point would be, well, yeah, you'd have to find this. Probably that point there, connector 4. But anyway, you connect your voltmeter across there, and you adjust that trimmer pot till you get 1.4 volts. Let's see how this is done. I've managed to find the connection points for the voltmeter. One, I got the leg of the transistor on the top end, and the other leg I got on the underside. And now I'm just going to adjust it. It's actually pretty close when we switch it on, 1.42. Let's try and be finicky about it. Let's get it a bit closer, 1.403. Okay, that's good enough. So one more done. Now, point number 3, they say set the supply voltage to 7.2 volts, and at a voltage of 7.2 volts, adjust resistor R640, which is a pot, set the display instrument in the battery control position so that the deflection of the instrument lies in the dry fit battery label, the middle field. Well, I think that's just setting your battery level meter. That shouldn't be too tough. Let's go and see what we can do. Supply is set to 7.2 volts. We find the appropriate trimmer by looking at the service manual as usual. And there we go. We connect the battery test and we can swing it left and right around what I believe to be that middle one, and that's done. Now they tell us to set the charging voltage. Now I'm not going to mess with this because I don't have a charger pack. This thing does the charge. You have a particular battery that is recharged with the main supply, and you fit that pack in there, and you can adjust the charger voltage to 9.1 volts, and you set it with a particular trimmer. Again, all that information is on the service manual. You actually have to put a resistor and a capacitor in parallel to simulate the pack, but I'm not going to adjust that at all because I don't have the pack. They tell us to let the pack run in for 2 minutes. Well, since I don't have the pack, I suppose that's a moot point. Let's carry on. Next page is the FM-IF alignment, 10.7 megahertz. I'm going to do this after I've sorted out the AM, but here's the information on screen if you want to do a screen capture. AM alignment. This is what I want to do now. Okay, so I want to do the AM-IF alignment. There are two IF alignments. There is a 460 kilohertz and a 2 megahertz IF. I'm going to do the 460. Actually, this is all sort of intermingled, but we'll start point by point. Bandwidth switched to narrow. They want this to be as sharp as possible. And you feed it a signal at 460 kilohertz with a modulated tone on it. The tone can be, in this case, they say less than 1,000 hertz. You can use anything that's audible that doesn't irritate you too much. I normally use, 800, 1,000, whatever the flavor of the day is. And now what they do here is they tell you what you're adjusting. In this case, you're adjusting IF filter 21, and the coupling point for the signal generator is 0.3 of filter 20. And I'll show you on the schematic what we're doing next. Loose probe on collector of T19, and you adjust 1 to a max. What the hell are we talking about here? Let's have a look at this thing. Okay, the general area that we're talking about is this area over here. So they tell us we are going to connect loosely to the collector of T19. Now loosely means what? Well, it actually means capacitively coupled. You don't really put a probe on here because you would shift this whole tuning out, but you capacitively coupled. And when I show you myself doing it, I actually solder a wire on here with an insulation on it. I just solder a piece of wire to the collector on the underside of the board, and then I either wrap another wire around it, which I use to connect the oscilloscope probe to, or you can actually just clip the probe to the insulation of that wire, and that should give you enough capacitive coupling to let you read the signal. What you're going to be getting here is the IF signal, okay? Because it hasn't been detected yet. This is the detector area here. It has not been detected yet. So what you're getting is the IF signal, 460 kilohertz. That's the wave you should see because that's the wave you're feeding in with or without modulation. You really don't need modulation for this sort of test because I'm going to be looking for the maximum amplitude of that carrier signal, okay? So couple on there, capacitively couple on there. And where do you feed it? Well, they tell you to feed it to pin 3 of filter 20, was it? We're adjusting this one here. We're adjusting this guy over here. And you're supposed to feed it into 0.3 over here. So why are we doing this? Well, you're feeding it in here. It goes through this, okay, which might not be optimally tuned, but it's good enough. This transistor serves as a buffer and amplifier, and it then allows you to adjust this guy without interference from your injection point, from your low impedance signal generator, for example, okay? So you're adjusting this filter from 460 to a peak. Now, if we take this one step further, they say that you adjust filter 20 and you have to feed it into 0.3 of filter 19. Then you adjust filter, this is also to a max. Then you adjust filter 19 and 18, and you injected 0.3 of filter 17. So let's go back. Right, so we injected there. Now we are going to inject there and we adjust this guy. Then we are going to inject there, and we adjust this guy and this guy. So we're basically just moving back, making sure that we have the optimal adjustments from the end backwards. So first that one, then that one, then that one, and that one. So these four will have been aligned optimally to 460 kilohertz, okay? Now you've injected in here, so you haven't adjusted this one yet. So once you get there, they say you then have to adjust filter 17 and 15 with that selected. Well, let us stop right here. Let's do these three first, and then we'll come back to that one, okay? I'm going to set it up. I'm going to send a signal from the signal generator at 460 kilohertz. I'm going to feed it into that point, adjust that guy, feed it into that point, adjust that guy, feed it into that point, adjust those two guys, always for a maximum amplitude, which I'll be looking at on the scope. Okay, let's do that. I've set this all up. I've got the little wire soldered to the transistor there. As I mentioned, it's got a insulated coating on it. I've connected the scope to the plastic coating, so it's not actually touching. It's capacitively coupled. The negative of the scope goes to the chassis. Here's the input. I've got it to that 0.3 of that filter over there, and we're going to adjust that one. So let's see how we get on. Now I'm going to switch on the signal generator and the power supply of the radio. Oh, we've got something there already. I had to increase the amplitude of the signal coming in because this is right at the end. There's not much amplification, so you just go up till you've got a discernible signal on the signal generator. And then all we need to do is adjust that guy. And I know you're not supposed to use a metal screwdriver, but I've noticed it makes no difference. And it's the only one I can get to go through this there. So let's see what we can get. I can sort of read 8.1 millivolts. 8.2, it's gone down. 9. That's a peak. It was actually there already. It didn't change anything at all. So now what I'm going to do is I'm going to move it one leg up, and I'll be adjusting that one, but I'm going to reduce the amplitude of the signal generator so that I don't get this thing blasting like crazy, and I'm trying to get to here. It's too high. Let's try 1 millivolts. Yep, it seems to be about it. Let's see what we get when we adjust this one. Again, I can't get through there with that screwdriver, the ceramic one, so I'll use the metal one and hope for the best. It's going down, up, down, up. That seems to be about the peak. It's not really easy to do this. It's very difficult actually, but we're getting there. Now we've got to go one step up and adjust these two. Now where do I go up? Well, it's literally to the top here. And again, I think I'm going to get a huge signal, so I'm going to increase the attenuation on the stepped attenuator. That's even more difficult to see, but we'll see what we can do. So both of these for max. Ooh. That seems to be a peak there. I'm not changing much at all, really. Pretty well aligned so far. It's going down, up and down. That seems to be about a peak. Okay, so we've done these three. These three have been set for maximum, as instructed, and as good as we can get. Okay. Let's see what we have to do next. What have we done? We've done this one, we've done that one, and we've done these two over here. All of these were for max, 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 okay? Now we need to look at this guy, filter 17 and 15 with shortwave 3 to 10 selected, and we inject at capacitor 223. And now they tell us 5 on symmetry and 7 on maximum and symmetry. What the heck are we talking about? Let's have a look. They talk about filter 17, so that's that one here. We know we were one short, we hadn't done that yet. They tell us to select shortwave 3 to 10, which is this guy here. So we are selecting up, okay? So this switch goes up, and therefore we are getting the signal from here. And there's 15, okay, good. So we're adjusting that one and that one. This one we adjust for symmetry and this one for maximum and symmetry. So we're going to have to sweep it, and we have to inject on capacitor C223. Where's capacitor C223? It's that guy over there. So we're injecting in here. It's going through all these guys. And this is where it gets a little bit tricky, because I believe these filters are set for 2 megs. This is the 2 megahertz IF chain. I'll try that. I think what I had to do is I had to inject 2 megahertz here, not 460. If we injected somewhere here, we'd be able to do that. But if we're injecting here, I think we have to go to 2 megs. We'll test it. But we have to adjust this one and this one with that selected up. But where are these guys? We're looking for, this is on the same one. This is that top one we saw. This filter 15 is on that 2 meg IF board, which I think is here. It's this guy here. Filter 15 is this one here, and C223 is this guy over here. Okay, we've got it. All right, let me get going. Now this gets a bit complex because I'm injecting it onto C223 as requested. I am reading off the same point over there. Now they tell us to adjust this guy, but here's the problem. That filter 15 is inside this, and you adjust it there. That's not a problem. The problem is that the signal that goes in here cannot be 460 anymore. It's got to be 2 megs, because this is in the 2 meg IF strip before the last transformer. And that last transformer before this mixer, before this this adjustment here, is still at 2 megs. And I've proven that because if I send, let's see if I can do that. Okay, now that's still too big, so let me give it a bit more attenuation. Now what I've got here is actually a 2 meg signal, not a 460. If I try 460 kilohertz, that's what happens. It disappears. It's got to be 2 megs. And I don't know how much I can really adjust this, because that depends on the precision of that 2 meg adjustment there. But I'll try it here anyway. I'll try this one. What I can't do is I can't do the sweep. Oh, I've got some more out of that one. I've got a bit out of that one, but I'm not sure that I want to do this one. But let me try it anyway. Let's see what happens. It was peaked anyway. It was at a peak. I got nothing out of that. I'm not going to try the sweep, because I don't know whether I need to sweep from 1.9 meg to 2.1. What am I supposed to sweep? I'm trying to adjust to 460 and get that bandwidth. What am I supposed to sweep? What I know I've done is I've got the peak on there. So I'm going to consider that one completed. So I think we can consider this one done, although we could only do maximum. We couldn't do symmetry over here. And now we'll go to filter 16 with medium wave selected, and we connect to the base of T12, and we have to adjust 6 for maximum and symmetry. Let's see what we're doing here. Filter 16. If we come back to the schematic, we've just adjusted that one there and that one there. But now we want medium wave selected, so that means this switch is down. So we follow this line here, 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 and this is filter 16. This is the one we're adjusting for maximum and symmetry, and they want us to inject the signal, I believe it's at the base of T12. So we have to see where we have to inject this. Let's have a look. Let's find these guys. Now filter 16 is over here, and T12 is here. So this is on that main front end board. So we adjust this guy here, and we have to do The base of T12 is over here. And where am I going to find this? I'm going to have to try and connect it to that resistor R404. Is that correct? Goes to the base of T12. Yep. If I can get hold of that resistor, I'm good. I'll find it, and that's the one we can adjust. And we're back to 460. Brilliant. So here we've got it. I'm injecting that to where I'm supposed to, the base of T12, and the adjustment is down here. I've had to reduce the amplitude. I'm at 460 again, and I'm just going to adjust that for a peak. It's pretty much there. And we're done. We are done. Good. We're back to the instructions, and we've done that guy. So we finished that section for now, and now we're going to the 2 megahertz AM IF calibration. And what they tell us to do is to adjust the oscillator. Now, what do they mean by this? We'll see in a second. They tell you to inject at C223, which is the same point we were injecting earlier. Output meter meaning we should actually measure the audio output, if I'm not mistaken. Yes. This has to be set to shortwave 3 to 10. It doesn't say here, but that is implied. And we're adjusting 8.8 for maximum. So let's have a look. So what are we doing? We're back to this section here, which is the 2 megahertz IF strip. We're supposed to inject on here, which is fine. And then we have to adjust 6. Is it 0.6 for maximum? No, it's 8 for maximum. And 8 is this one here. So what are we doing here? We're sending 2 megahertz in here, and we want to make sure that it comes out of here peaked at 460. So we have to adjust the oscillator. And what we're really doing is making sure that this oscillator is adjusted to 2.460 megahertz. So 2.46 megahertz, it adds or mixes with the 2 meg you're sending in here, and you get 460 coming out here, and that goes through the whole 460 IF block. That makes sense. So we'll do that. And then the next step is filter 14, 13, 12, and 11 at the base of T5, and you adjust all these 9, 10, 11, 12 for maximum. So base of T5. Where are we? We're back to this boy over here, and we have to look for the base of T5. Where's T5? There's T5. The base of T5 is this one here, and they tell us we can use this clip over here. So Z2, I think it was. Yeah, we can actually clip to Z2, so it goes to the base of T5, and then we adjust 9, 10, 11, and 12 for a maximum output. And if we look on the schematic, we're sending the signal here to the base of T5, and we're adjusting all these for maximum. There. So that is the 2 megahertz IF strip. That's the 2.46 megahertz oscillator, and that's the filter for the 460. So it makes sense. It should be quite simple. Let's get this done. Now to adjust the oscillator, it's that guy over there. It was all sealed up, and I'm actually looking at the meter. I've got a meter across the speaker. I can hear it, but I've taken the wax off, and I'm just going to peak it. It's not in properly. This is very sensitive. There, I think I've got a peak. That's my peak. I can see why they waxed it. It's a pretty difficult one to adjust. Okay, the next one. I've now set this to pin Z2 on there. And we have to adjust 9, 10, 11, 12. And I believe it's these guys over here. Well, here's one. I'll keep my eye on the meter. This doesn't seem to be needing any adjustment at all. I've done that one. This requires a different... Oh, here we go. No, that's perfectly aligned. I'm looking at the meter at the same time as I'm doing this, and I'm getting no difference whatsoever. Nothing. That's peaked. Everything there is peaked. Turn that noise off. Okay, that is done. So it seems we've done quite a bit. We've done the oscillator and we've done these filters as well. And it means that as far as we're concerned now, the entire AM alignment, the IF alignments are done, are completed. And once we've done this, we then have to carry on. We can carry on and do the RF alignment, which I'm not going to do right now. I've got some cleaning to do. I've been desperately waiting for the cleaning. But this part is done for the AM. The FM I'm going to leave for now. I want to check what we've done so far, see what it's coming out as, and then we'll take it from there. So I'm going to do some cleaning. I'm going to clean some contacts. To hear me speak, you'd almost think I'd enjoy this stuff. Actually, I do. I'm a weird one like that. This is cleaning all the little pins, those spring clips on the drum tuning mechanism. These guys get incredibly tarnished, and you really do have to clean them up. And what I do is I use a fiberglass brush with gloves, because these things make your hands very uncomfortable. Those little bristles become like thorns. And then I clean it off with some isopropyl alcohol. You've got to do all of them, okay? It's tedious, but you've got to do all of them. Do them well, do them carefully, because this is what makes those bands work or not. And then, of course, we get to the plates, those face plates that give you the different bands on the Shortwave 3 to 10. Just giving each of those a clean. If you remember, a lot of them were removed. They sort of fell out. So I'm just cleaning them with isopropyl alcohol. These are going to come out again when I need to do the RF alignment for each band. But in the meantime, I clean them and slowly, carefully fit them back. You've got to rotate the drum sort of to halfway between two different fixed positions, so you have good access to the fitting for the plate. And of course, I've just taken the order, the frequency band order, and I know that those are the correct places for these plates to go into. But you've got to be careful, because you don't want to bend anything, you don't want to break anything. So make sure they fit carefully and you fit that in. Then of course you can just clean the others as well, but as they're going to come out again, I'm not going to focus too much on that. All right, let's give this a quick test. I've got this on Shortwave 3 to 10. This was the area that was very iffy. At the moment I've got it on 6, so 25 meter band. This is evening. This is about 11 to 12 megahertz and below.
Je voulais faire du dessin animé, mais je me suis bien vite rendu compte que le dessin animé, en fait, ça demande beaucoup de moyens, ça demande des équipes. الثاني شيء للمناسبة الفكرية العالمية الحديثة بقيادة الأمير العام الأستاذ أحمد الله. Finalement, moi, tout ce
Let's try slightly lower.
A manifesté un peu partout dans l'Hexagone contre l'affiche du second tour de la présidentielle et contre l'extrême droite. Il y a 20 ans déjà, plus d'1 million de personnes défilaient contre l'actuel. International de Canada.
Pretty good, pretty good. Let's go lower. Lower in frequency. Got some SSB transmissions on here. Okay, let's try the 49 meter band. Okay, that's good. That's good. Let's try medium wave.
José Pedro, foram momentos de grande simbolismo.
Se hace cargo de las investigaciones. El ayuntamiento. Recordamos que es el teléfono de la técnica.
Último partido ante el Barça. Seguimos en Barcelona, donde los Liga solo le separan 9 puntos, aunque también está el Barcelona.
Es el área Jesús está tratando de identificar y localizar a dos personas que pararon a una moto. Los atacantes efectuaron varios.
So a lot of stuff from North Africa and the Canary Islands, as expected. Try long wave.
الأيام القادمة لأول مرة وجود القوات الأجنبية المشاركة إلى جانب النيجر في القتال ضد
هذه خيارات عدة ومن أجل ضمان السيادة في هذا المجال قالت ليلى بن
This is BBC Radio 4. Our beacon. So this is working very well. This is working very well. I've tried the shortwave 3 to 10 as expected, above around 15 or 12 megahertz. We don't get anything at this time of night, but everything is reacting as expected. It's actually pretty sensitive. The lower bands are working well. Haven't tried shortwave 1 and 2 because there's nothing at this time of night. Actually, I don't get much here anyway, but they're working. Just give it a quick try. A lot of data on those bands. So what have we achieved? Well, it looks like the AM sensitivity is up and it's working very, very well. All the bands are working. I haven't done the RF alignment. I've not checked where they are in relation to the band. I know that for at least the long wave, I'm getting the beacon where I expected, just slightly off, so we'll need to do an RF alignment. Medium wave, same story. I know that I'm getting the Portuguese station here at 1.5 something, and it's actually on 1.530. So any of these bands, I'll have to do the checking, send the known frequency signals and do the alignment. FM, I haven't got to yet. I've got the problem with the low volume on the FM. Don't know what that is. I don't know whether it's an IF issue or a sensitivity issue. We'll come to that. But for now, I'm pretty happy with all the progress that's been achieved so far. Our AM, IF alignments have been done, and everything seems to be working as expected. So I'm going to stop for now and carry on doing some research on the FM section, report back when I've got something to tell you. And for now, I want to thank you for watching. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now and stay safe.